Actually recording? There it is. I'm just going to go through the stretches around the XY axis part 2 really quickly here. So these are all the note stuff. This is what we found out in that first part. So I just have to write the equation. The stretch around the y-axis by a factor of 3/4. It's just going to be y over 3/4 equals x squared. Or I could write that as 4y over 3 equals x squared. Or I can just write this as y equals 3/4 of x squared. Again, I personally prefer that whole idea of replacements, right? I've replaced y old with y new divided by my scale factor, which is in this case 3/4. So that's the way I prefer to do it. Here we go. Horizontal stretch by a factor of 4, so that's going to be x old gets replaced by x new over 4. And then a vertical stretch by a factor of 2, y old gets replaced by y new over 2. So this is then going to be y over 2 equals absolute value of x over 4 minus 3. Right, so I just made my replacements. Now, this is actually a really tricky question. It shouldn't be, but it is a really tricky question because if you have memorized instead this thing that is just y equals a times f at x, if you've memorized it like this, then what people will sometimes write is this. Y over 2 equals, or sorry, let's try that again. I'm doing it my way. Y equals 2 root x minus 3. And in fact, it would have to be that, because that minus 3 existed before the vertical stretch. So you'd have to include your brackets. Here, we don't have to worry about it. The replacement takes care of it for us. So horizontal stretch by a factor of 1/3, x old gets replaced by x new over 1/3, or 3x new. So this is going to be y equals 3 times 3x new plus 7, or 9x plus 7, once I simplify it out there. Replacement here, this is going to be a horizontal stretch by a factor of 2. This is going to be a horizontal stretch by a factor of 1/3, again, because that would be like x over 1/3. Oh. If I move that to the denominator so I can see it more closely. Again, I would prefer to do something like this. Y over -2 equals absolute value x. So this is vertical stretch factor 2 and a vertical reflection. Or you could even just say vertical stretch factor -2. I'm okay with that. This is the way the diploma will do it, but I can do it either way. Vertical stretch factor 1/3, horizontal stretch factor 3, vertical stretch factor 2, because it would be y over 2 equals absolute x over 3. And then here I have this in the brackets, so this is going to be a horizontal reflection, that's the negative part, and then a horizontal stretch factor 1/2. Here I'm just looking at what happened. It didn't change horizontally, it did change vertically from 6 to 3, so this is going to be y over 1/2 equals 6x squared plus 1. I could multiply that to the other side if I really wanted to. And that's the thing about the y. You can either write it in replacement notation or mapping notation. But again, if you do it like this, you've got your mixed notations. I've got mapping and then replacement. And that's kind of ugly. It's better to, I think, personally do it in replacement notation. Here, since this thing is the thing with the kind of curvy bit, and this thing is the thing with the curvy bit, I can see that it was vertically reflected. And here it went up 3, here it's going down 6. So it's a vertical reflection and a vertical stretch by a factor of 2. So y over negative 2 equals f at x, or y equals negative 2 f at x, depending which one you want to use. And here I can see that it's not a vertical change, but it is a horizontal change. So this point went from here to there, 1.5 to 3. This point goes from about 4 to a little bit past 8. So it's a vertical stretch, or sorry, horizontal stretch by a factor of 2. So y equals x over 2 plus 4, x over 2 minus 2, x over 2 minus 6. Or if I really wanted to, it'd be easier to just go, it's f at x over 2. So the zeros of this thing and the x and y intercept. So in this case, it has x intercepts 4, negative 3, and negative 6 that I can just see out of the factors of those things. The y-intercept is when x is 0. So that'll be negative 4 here, positive 3, positive 6, 12 and 6, 72, negative 72. So 0, negative 72. If I have this, I would prefer to write it like this. So here I can see it's a vertical stretch by a factor of 3. And what that tells me is that it's going to get bigger. So the y-intercept is going to change. The x-intercept will remain invariant, 0, negative 216. Horizontal stretch, in this case, it's a horizontal reflection. Oh, shoot, I didn't even catch the reflection. See how that's a negative number there? That's going to be a reflection, so it'll be 0, positive 216. Whew, look at me go. Y equals p at negative 1/2 x. It's going to be horizontal stretch factor 2 and horizontal reflection. Therefore, all of those x-intercepts are going to switch sides and multiply by 2. New x-intercepts are going to be negative 8. Again, 0. Positive 6, 0. That's if I flip this one around. And then positive 12, 0. It's going to be my new x-intercepts there. And that's that. Hopefully that all makes sense. Come in if you got questions. We have